evening, everybody. Welcome to our Spring Magi Lecture, Your God is Too Small. I'm Jessie Taylor, a physicist at St. Joseph's University and the director of the Magi Project. The Magi Project exists at the intersection between science, philosophy, and religion, and works to facilitate dialogue across these disciplines. Through courses, conferences, public talks like this one, and various other outreach, we invite students, faculty, and anyone else who is interested into conversations that explore the fundamental questions of the universe and our own place within it, through the distinct but complementary approaches of science, philosophy, and religion. I'd like to thank the Lumen Christi Institute, supporting the Magi Project through a grant from the John Templeton Institute, as well as our co-sponsor this evening, the Thomistic Institute. And also, let me express our gratitude to the Newman Center for this lovely space for tonight. Tonight, we turn our attention to the vastness and wonders of the cosmos, and I'm very pleased to introduce our distinguished speaker, Brother Guy Consolmagno. Brother Consolmagno is the president of the Vatican Observatory Foundation. He served for 10 years as the director of the Vatican Observatory after being appointed by Pope Francis in 2015. Brother Consolmagno received his BS and MS in planetary science from the Massachusetts Institute of Technology and his PhD in planetary science from the University of Arizona, following postdocs at Harvard University, MIT, and a stint in Kenya with the Peace Corps. He became an assistant professor of physics at Lafayette College, where he taught until his entry into the Jesuit order. He was assigned to the Vatican Observatory in 1993. Since then, his work has taken him across the world, and to highlight just a few of the many things, from the Loyola Chair at Fordham, to Antarctica, to being a visiting scientist at Goddard Space Center. Brother Consolmagno's research explores the connection between meteorites and asteroids and the origin of evolution of small bodies in the solar system. The International Astronomical Union recognized his work by naming an asteroid after him. He is a fellow of the Meteoritical Society, a recipient of the Carl Sagan Medal for Outstanding Communication by an Active Planetary Scientist to the general public from the American Astronomical Society, and a recipient of the St. Albert Award from the Society of Catholic Scientists. He is the author of numerous academic articles and many books, including most recently, A Jesuit's Guide to the Stars, Exploring Wonder, Beauty, and Science in 2025, Finding God in the Universe, 2022, and God's Mechanics, How Scientists and Engineers Make Sense of Religion. We are delighted to have him with us tonight. And that, let me turn things over to Brother Guy.
Thank you so much for coming. I see a few friendly faces here, which is great. And I was trying to decide whether I wanted to make this a more academic talk or a more gosh wow talk. And so I'm going to do showing lots of pretty pictures with a point behind them. And then if you want academics, we'll do that in the Q&A. But I start with one of my favorite academics, Chesterton, who writes, "The earth is so very large, and the cosmos is so very small. The cosmos is about the smallest hole that a man can hide his head in." Which is, Chesterton, the master of paradox. Think about that. Think of what it is he was trying to say. We'll come back to that at the end, maybe. On the other hand, another theme that I'm going to run through this is Psalm 139, a psalm that I thought of when I was traveling around the world to get into the Jesuit Observatory, and then one that hit me once again during my time when I was in Antarctica looking for meteorites. "O Lord, you have searched me and you've known me. You know when I sit up and when I rise up, sit down and rise up. You discern my thoughts from far away, search out my path, are acquainted with all my ways. Even before a word is on my tongue, O Lord, you know it completely. You hem me in, behind and before, and lay your hand on me." So we're stuck with two interesting mysteries. One, that the cosmos is a tiny, tiny hole in our head. And the other, that the God who made the universe hems me in and knows me better than I know myself. And these are the two questions I want to come back to and think about through the rest of the talk. But first, a story from a good friend of mine, a fellow science fiction fan, who this is dating from more than 20 years ago when the very first Mars exploration rovers landed on Mars.
our last storyteller is Steve Collins, and Steve is the attitude control manager on NER. Actually, until this morning, I didn't have any idea what Steve was going to talk about, and when he told me the difference between abstract and reality for him, I think you're going to find his story very, very interesting.
Thank you, Firuz. I'm actually just one of the many ACS engineers. Kind of our boss is Miguel San Martin. And I wanted to tell you a story today about an event that happened a few weeks after the two landings. I'm an attitude control system engineer. I'm responsible for the gyros and the thrusters and the software that keeps the spacecraft or the rover pointed in the right direction. And as such, I live in this world of numbers. And sometimes it's hard to go from those numbers to the picture of what the spacecraft is doing. But that's kind of the job, is to figure out from the numbers, what direction is the spacecraft pointed today? So a few weeks after the landings, we were kind of in a groove at that point. We were living on Mars time, and so we were coming in at weird hours and not sleeping very well. And so it was the middle of the night, and I was in the control room. I was just coming off shift, and somebody, one of the other engineers, came by the console and kind of just tapped me on the shoulder and said, "Go up to the 6th floor and check out the pictures." And then he kind of went away, and it was kind of like it was a secret, or something special. And so I went up once I got off shift, I went up to the 6th floor to the UN Conference Center. That's what a lot of you know the room I'm talking about. It's this large conference room where the science working group makes their, argues about who's going to do what with the rover the next day. And it has a big U-shaped table and microphones at all of the chairs, and it looks like the UN Conference Center. One of the things that they have in there is this high-resolution projection TV that's goes onto a screen 15 feet wide. And so I go in there, and the place is dark. It only gets used a few hours a day when the science team is making all these critical decisions about the rover planning. But so I go in there, and it's dark, and it's quiet, and there's a picture up on this big high-resolution screen. And you can't really make it out. And you can't really make it out because it's in 3D. And it's in the fancy kind of 3D, not the red-green glasses kind, but the kind that takes a set of special electronic glasses. And when you put them on, you can see the picture in color, in the actual natural color, but it's in 3D. And so I go in there and I step to the center of the room in the middle of this big U-shaped table, and there's a pair of glasses there on the table, and I put them on, and I'm standing on the surface of Mars. You can roll the clip that we have of this. And what I'm looking at is a color, high-resolution panorama of the Spirit landing site, and it's in 3D. And off in one corner I can see Sleepy Hollow, which is a sand trap that we decided we wanted to be careful and not drive into. And the thing slowly pans around, and as it pans around, you can see where the airbags have been drawn back up and left scrape marks in the soil. And then we pan around a little bit farther, and off in the distance, there's a line of mountains you can see, and as it goes farther, you can see the whole expanse of the Columbia Hills out in the distance. And it's changed from being a set of numbers, on these telemetry screens to being a place. It's a place. And I'm thinking, I wonder if we could drive the rover all the way over to the Columbia Hills. I mean, could we possibly do that? I sat there in the dark by myself for maybe 20 minutes and just let this panorama scroll by, and thought about, holy cow, look at what we've done. It's a place. That's the view that an astronaut is going to see when they step out onto the surface of Mars for the first time. So I went back downstairs to the MSA and tapped my buddy Tony, who had just replaced me on shift, and I told him, when you get a chance, when you have a chance for a break, go up to the 6th floor and check out the pictures.
If you're interested, Steve Collins has an interesting background. He has a master's degree in theater. And if you know storytelling, you could see a lot of marvelous technique going on there. I can't do it in 3D, but I do want to give you a sense of the surface of Mars. And I'm not always going to be looking at the spectacular things, but not the Grand Canyon of Mars, but the Nebraska of Mars. It's a place. It's a place where we can walk around. Or at least our robots can walk around. It's got an awful lot of the same geometry and geology that the Earth has. Stratigraphy. You can work out the history of the surface by looking at the different layers of rocks. The rocks piled up when impact craters occurred. As we got a little bit bolder, we started landing spacecraft closer to mountains. And coming up from the orbiter, you can see craters with their own history. It's not only a place, it's a place where things have been happening for the last 4.5 billion years. What look like pools of water, it can't be water because there's so little air in the atmosphere that the water would evaporate immediately. But it sure looks like a fluid that has carried material out from inside Mars. People will argue from place to place, is it water that then evaporates? Is it carbon dioxide? And that's sunset on Mars. Be praised, my Lord, through all your creatures, especially my Lord, brother, Sun, who brings the day. You give light through him, and he is beautiful and radiant in all his splendor. Of you most high he bears the likeness. Let's go back to Psalm 139. Such knowledge is too wonderful for me. It is so high I cannot attain it. Where can I go from your spirit? Where can I flee from your presence? If I ascend to heaven, you are there. If I make my bed in Sheol, you are there. If I take the wings of the morning and settle at the farthest limits of the sea, even there your hand shall lead me, and your right hand shall hold me fast. Out beyond even the sea on earth. Be praised, my Lord, through Sister Moon. An image that most of us have seen at one time or another from the Apollo. Here's one you may not have seen. From one of the poles, I believe the North Pole of the moon, imaged by a Japanese spacecraft. We've walked there. I know that guy. He is right now attending a science meeting in Houston, the Lunar and Planetary Science Conference. That's Harrison Schmitt. He's in his 90s, and he's still interested in astronomy and the moon and what it's like to work on the moon. And if you're a nerd like me, you'll see this picture and not only be amazed at what it took to go there, but you'll also ask, how come the dust is sticking to his knees? It's not water. What's causing it to stick? How strong is the soil? If I wanted to do what Harrison Schmitt wants to do and go to the moon and scoop up tons and tons and tons of it and extract helium-3, which turns out to have an enormous value as a coolant in quantum computers, for instance, how hard would it be to dig up the soil? How heavy is it? How much does it stick together? When you go deeper, how fast does it become strong? At what point does it stop acting like... I just actually went to a PhD in defense by a fellow who's been working on these questions, University of Central Florida. And he says, it's not soil. Don't call it soil. It's a completely different kind of material. And one that our intuition is maybe dangerous to try to figure out. You don't have to go quite that far to get to an exotic part of the world. These are pictures I took on my way to Antarctica, where I was part of a team of scientists who lived in tents like those. One of those is my tent. We were there to live in tents for 6 weeks, to drive across the ice and collect meteorites, which are rocks from other planets. But being there felt like you were on another planet. This picture was taken at midnight. All right, which way was I pointing the camera when I took the picture? Pointing to the south, because the sun is over the South Pole, looking down at me. Why was I up at midnight? Well, what do you do when you have to get up in the middle of the night? One thing you do is you walk downwind. The wind flows downhill. The South Pole is roughly the highest part of the ice cap, and the wind slides down till it hits the oceans. The ice also slides down, and it will compress and move the ice so that the meteorites that fall on the ice wind up collecting themselves in front of mountain ranges. But sometimes, though most of the time it's a desert, sometimes it snows, and then you're stuck in a tent waiting for the wind to blow the snow away. One of our group read War and Peace. I read this big biography of Eleanor and Franklin, and we ate a lot of chocolate. 2 big Cadbury bars a day, and I still lost weight. But it's a world of ice. Be praised, my Lord, through brothers wind and air and cloud and storms, and all the weather through which you give your creatures sustenance. When it cleared, we would get on skidoos and just go back and forth, looking for anything that wasn't ice. and collecting it. Sometimes you wind up going up and down hills. A guy brought ice skates, said it was the first time he'd ever had to ice skate uphill. And sometimes you'll see patches of snow. That's not snow sitting on the ice. That's a crevasse. You don't want to walk across it because you might crash through into a crack. It's a different world. But it's a place. And when the clouds come and the shadows go away, you can't tell where the ground ends and the sky begins. Except when the mountains come through. It's a place. That's me. That's me. I did that. That was impossible. It's not the only place that's wonderfully weird. Even here on Earth, we can see places where the rest of the universe has reached down and touched us. Meteor crater. That's the same guy over and over again as I took numerous pictures and glued them together. The moon is covered with craters, and we can understand craters by looking at the impact craters we find on Earth. But the Earth also has volcanoes, which in some ways remind you an awful lot of Mars, except that here the sky is blue, not red, and there's water clouds in the sky. And off in the distance, telescopes. And I did promise you, Nebraska, but here's a bit of the Grand Canyon. If I say, surely the darkness shall cover me and the light around me becomes night, even in the darkness, it's not too dark to you. The night is as bright as the day, for darkness is as light to you. Well, actually, I was in Antarctica where the sun never set, so it really was light all the time. For it was you who formed my inward parts, you who knit me together in my mother's womb. I praise you, for I am fearfully and wonderfully made. Wonderful are your works, that I know very well. Every 120 years or so, Venus and the Earth are lined up in such a way that from Earth we can see Venus cross across the sun. And this is what happens twice every 120 years. The last two were in 2004 and 2012. This is a view taken from the roof of the Pope's Observatory in Castel Gandolfo by a friend of mine, Rand Antowitz. Venus and the sun. I can't see these pictures without remembering. We had dinner in a beautiful restaurant in Castel Gandolfo overlooking Lake Albano afterwards. His wife joined us. Her stepfather joined us. Her stepfather was someone about my dad's age, with a number tattooed on his arm. This is also the universe we live in. This is planet Venus. This image actually was taken by a Russian spacecraft in the 70s, but really we could only see it like this after computer technology was strong enough to unbend it. The air on Venus is so thick that if you stand there and look, you will think that you're inside of a bowl, because the air bends the light and the horizon seems to be bent above us. The cameras only lasted about 20 minutes because the atmosphere is at about 800 Kelvin, or maybe it's 800 Celsius. At that point, it doesn't matter. And it's about 100 atmospheres, and the clouds are full of sulfuric acid. We could do that here, We're on our way right now. Put a little more CO2 in the atmosphere. Now, my own love are for these small guys. This is a little moon of Mars. This is Deimos. And a guy that I spent an enormous amount of time in research, asteroid 4 Vesta. And if you want to know more about Vesta, catch me for about an hour. And this is a marvelous view from the Juno spacecraft of our biggest planet, Jupiter. The Juno spacecraft was one of 5 proposed one year, and a panel had to go through the different proposals. On the panel with me, I was one of the guys in the panel, on the panel with me was a fellow who said, "Guy, do you remember me?" I go, "Not really." He goes, "I was in high school with you," but he was 2 years behind me, so who remembers that? "And I was at MIT when you were there 2 years behind me, and our dads worked together in Detroit. While we were at MIT, we both dated the same girl, maybe at the same time." It's a small world. The people who make the images like this are friends. They're clever, but we know lots of clever people. It's things that we could do, that we have done. And in the process, we can look at the clouds of Jupiter and try to understand. On Earth, we've got a planet that's spinning, but it has a solid surface, and it's tilted. And in Venus, we've got a planet that isn't spinning. And on Jupiter, we've got a planet that spins way faster. How does the spin rate affect the way that clouds behave? Nature is doing the experiment for us. All we have to do is look. Jupiter also has its moons. Look at Io. Some people want to pronounce that Io, but I know it's Io. The one thing that we all agree is it's not pronounced like a newscaster once said, "Volcanoes have been discovered on Jupiter's moon 10. Notice the volcano. You can see the cloud of the volcano. You can actually see the volcanoes. You can see them erupting. And in many ways, these can be observed also, now that we know where and how to look, with the James Webb Telescope that looks in the infrared so that the volcanic areas are really bright, from other telescopes here on Earth. Spacecraft do give us a different point of view. This is Saturn, as seen by the Cassini spacecraft from the side. Where is the sun in this picture? Off that way. You can see the shadow. Where is the Earth? Same place. Saturn also has moons. The moon Titan is much bigger than Earth's moon, and it has an atmosphere of nitrogen, twice as thick as the atmosphere here on Earth. And it's only one of many moons. This is another little moon in front of Titan. And we actually landed on Titan. The lander was made by the European Space Agency as part of the joint Cassini-Huygens mission. This is an image coming through the clouds. Titan is covered with lakes. And the clouds are not clouds of water because it's way too cold, but clouds of methane. And the lakes are liquid nitrogen and methane. And the rocks on the surface are made of solid, hard as rock ice. But it's a place. It's a place where you could walk around. And of course, Saturn has these marvelous rings, which at one point I understood this picture, and I keep going back and it's part of it's the shadow, and part of it's the shadow of the ring on Saturn, and it's and then there's this marvelous moon, which has got a black spot on one side of it. And when we finally went and visited it, we discovered that there's a ridge running around the equator. These are images glued together in a computer to make it move, but all the actual images are real. Remember I said that Antarctica was a place of ice, almost like a planet of ice. My master's thesis at MIT in 1975, before we had any of these spacecraft, was about moons made of rock and ice. And I did a clever calculation. I only underestimated the heat flow by a factor of 10 and the heat generation by a factor of 10, so the two mistakes canceled. And predicted that there would be water underneath an ice crust. I did not predict that I would live long enough to see that water coming through cracks in the south pole of the Iapetus. Be praised, my Lord, through sister water, useful, humble, precious, pure. And another bizarre moon that looks like a lot of stuff has been evaporated away. This is an interesting view of Saturn. Where is the sun in this image? It's on the other side of Saturn. And when you see the rings, they look odd because the rings we're used to is where the light is reflected back, but now we're seeing dust rings where the light is scattered forward by the dust, like dust in a room where a sunbeam is coming through a window. But if you look very, very carefully, right there, there's a tiny dot of light. That's us. Be praised, my Lord, through our sister, Mother Earth. My frame was not hidden from you when I was being made in secret, intricately woven in the depths of the earth. That's where we were made, that little dot. Your eyes beheld my unformed substance. In your book were written all the days that were formed for me, when none of them as yet existed. I try to count them. They're more than the sand. I come to the end and I'm still with you. How mighty to me are your thoughts, O Lord. How vast is the sum of them. And then, there are the stars. In the heavens, you've made them bright and precious and beautiful. A collection of galaxies. The Whirlpool Galaxy. A galaxy where another galaxy has passed through it. And within that galaxy, a star that has exploded and died. And what we're seeing here is not the explosion of a star, but a burst of light from the center star, moving at the speed of light, illuminating a gas cloud around the star that we would not have seen otherwise. These things are all out there right now. This is not something from, the dream of a science fiction artist. There really are unicorns. And stars being formed. Little hint. If you see a star with 4 spikes, it's a Hubble picture. If you see it with 6 spikes, it's a James Webb picture. Because the Webb had 3 struts holding up the secondary mirror, and that gets duplicated. And we're seeing planets around other stars, just to remind you that we've got some interesting planets too. Jupiter in the infrared. When I was a student, I was taught that the sun and the planets were made from a cloud of gas and dust, kind of like a frisbee. And then one day somebody came in and said, actually, I've done the calculation. It's more like 2 frisbees, one on top of the other. We all laughed at him. This is what we can now see. Looking at actual pictures of what we're studying shows us where the interesting things are, the context of where it's happening. And also, it motivates us because we see this beauty. We desire truth. Hubble versus James Webb. Hubble shows the dust, Webb looks through the dust. And galaxies among the farthest, most redshifted galaxies as they looked at the beginning of the universe. The universe is filled with beauty everywhere we look. The things we see delight the human eye. Doesn't matter how much astronomy you've had. But when you have studied it, your soul finds joy in the expression of the laws of nature that these images reveal. We find beauty not only in contemplating creation, but how that contemplation allows us to understand and to come up with new questions to follow. The glory of creation reflects the magnificence of the Creator. Psalm 19, of course, tells us the heavens declare the glory of God, but here the heavens are declaring things that the psalmist could never have imagined. And yet anybody seeing them can taste what we feel as astronomers. When our telescopes capture the cosmos, touch the face of the Creator. Our sun, be praised through brother fire. Bright in the night, beautiful, cheerful, powerful, strong. And a little bit of a meteorite thin section, because after all, that's my field. How does all of this compare to what Genesis told us about the universe? You might say, well, we're so much smarter than those guys. Well, no. We're only smarter in that we got ourselves born 2,000 years plus 600 later. Genesis, the science in Genesis is this science, and this was the best science of its day in the time of Babylon. The world is flat, there's a dome, there's water above and below, and the Babylonians had this marvelous theory for how the universe was made. You see, the gods were having a big fight, and the dragon Tiamat showed up, and they killed the dragon, and the body of the dragon becomes the dome that we're all living in, and we human beings were kind of made by accident, but without the gods knowing about it, we all got together and created the most marvelous thing in the history of the human race, the city of Babylon. Now, the Babylonians also captured the Jewish intellectuals in what's called the Babylonian captivity. And those guys were working for these guys and wondering, what are our kids learning? Is that really what we want to think, that the city of Babylon is the ultimate? Genesis is written not to tell the story of how the universe was made from a scientific point of view. It's not about creation, it's about the creator. And it stands in opposition to the Babylonian myth. It starts out, in the beginning, God's already there. What does that mean? If God's already there, then there is something not universe, but still in existence. And that's important. Wittgenstein once pointed out that meaning cannot come from the thing itself. So when Steven Weinberg or Bertrand Russell talk about a universe without meaning, they're right if they limit the universe to something that doesn't have a God. But Rabbi Sachs in this book argues the idea that the universe is meaningless without God, you can find in the book of Ecclesiastes. Vanity of vanities, all is vanity. He says you could read that as meaningless, meaningless, utterly meaningless. Everything is meaningless. Man's fate is like the animals. The same fate awaits them both. Unless there is a God outside the universe. Wittgenstein says a chair only has meaning if there's a person in the chair, sitting in the chair. What else does the story of creation in Genesis tell us? It tells us that there are no nature gods. There's only one God. So if there's not Zeus throwing the lightning bolt, then who is? It tells us that the universe is made deliberately. God chose it. It wasn't by accident. And at every step along the way, he said, this is good. Or as a Jewish engineer friend of mine put it, yeah, you could translate as God saying, yeah, that works. This is an essential element in all of the Abrahamic races, Judaism, Christianity, Islam. It is by a deliberate decision that the Creator made the study of nature possible. And that means that science is something that God invites us to do. Genesis says that the universe is made as logically as day follows night. Since the beginning of time, God reveals himself in the things he's made. And finally, what is the point of creation? What is the most marvelous thing that God creates? Not the city of Babylon. What is all of the 7 days leading to? What's the most wonderful thing? Human beings are made in the 6th day. Nope. It's not human beings. It's the weekend. It's the day of rest. It is saying that we were made for more than just to be animals that feed ourselves and sleep, but that we are given a time when we can do things that don't just fill your stomachs, like astronomy, or art, or music, or dance, or all the things that make us human, rather than just well-fed cows. Genesis says that the God who made all of this is the God who made us deliberately, and the God who gave us the opportunity to appreciate him.
Well, doesn't all of this just make us feel smaller and more insignificant and destroy the thought that God just made me and just made you?
Well, I think it can only do so if we have the wrong idea of God. The problem is we never make God big enough. And that's true of us, it's true of people who professionally think about God. Some theologians don't make God big enough. God is big enough to make everything important. We're not. We have to, I pay attention to you now, I can't pay attention to other people. We're limited. God's not. God can make everything in the universe important, and that's what God does, because God made it and God found everything good.
So even though the science was obsolete 100 years after Genesis was written, the theology is eternal. There are many different creation stories in Scripture. But though the science changes depending on when the story was written, the theology is constant of a God big enough to do all of that, who loves us individually. I end with a story. 10, 15 years ago, I was cruising the internet looking for something totally different. And I have no idea how or why, but I stumbled on a column by the gardening columnist for The Independent. It's a British magazine, newspaper. Her name is Emma Townsend. But in this particular column, she wasn't writing about gardening. She was writing about her childhood. She grew up in England in the 60s and 70s. Her dad was away from home a lot, but when he was home, this was the most marvelous thing. She was really close to her dad, and her dad to her. And all the times that he would come home from work, it was like a celebration, because in her eyes, her daddy was the most marvelous. He was a rock star, he was just the best thing going. And I hope any of you who have, in a father-daughter relationship can relate to that, can relate to how a parent is that close to you. And then, when she was about 11, she describes how she discovered why her father was away from home a lot. Her father, Pete Townsend, really was a rock star, lead guitarist for The Who. We are in that same relationship with God. We know God intimately as the daddy who loves us. But he also happens to be the God who did all of that. Putting the human equation back, I end with Chesterton as I began. The essence of all pantheism was that nature is our mother, but the point of Christianity is that nature is not our mother, nature is our sister. Now, nature was a solemn mother to the worshippers of Isis and Cybele, to Wordsworth and to Emerson, but to St. Francis, whom I've been quoting here, nature is a sister and even a younger sister, a little dancing sister, to be laughed at as well as loved. Of course, nature is our sister. We share the same Father. Thank you very much for coming.